I want you to imagine for a moment that an architect's office. What does an architect's office look like? Maybe in your mind's eye, you're thinking of drafting tables, big luminous windows, maybe fancy pencils, maybe tucked behind the ear. And, you know, if you think about it, we often would think of the desk that looks like an architect's desk. And so if I asked you about the one on the right, whose desk is this? Is this an accountant? Is this a CEO, a graphic designer, maybe a software engineer? Maybe my desk, although the plant looks healthy, so probably not my desk. Maybe even your desk, although yours is definitely messier than that, for sure. Okay, so what I would say is we essentially have this idea of convergence. So that desk on the right looks like everybody's desk because there's been a convergence of the different types of work, and they look very much alike. So I'm here to talk about software engineering, and my name is Sam, and I'm a software engineer. I've been in the industry for a long time, and it is something that I teach. And I will say that I live in the future, the near future. There's no flying cars in my world. There's cars that can drive themselves. Well, that's one way to put it, I suppose. And so essentially, the reason why I talk about that is because I think a lot about kind of the systems and the processes that are a part of that world around me. And it seems to me that there is something of a large amount of influence coming from the software engineering industry. And so what does that look like, and how does that take place? So if we think about that desk on the right, the question is not just, is there a convergence in the stuff that's on the desk, but also, what about the applications on the computer? In other words, are we seeing the same sort of thing happening? If I asked you right now, what's in your pocket, other than lint, you might talk about your keys, or possibly, an ID or something like that, but also maybe the small supercomputer that has an instantaneous connection to all of humans' knowledge, right? Essentially your smartphone. And so if you think about it, what does that represent, and how is that relevant to what I'm talking about? And so when I talk about tool conversion or tool convergence, if we look we have all of these architects' tools, and very classic, right? These would have all been replaced in some form or another by the computer system and the other things on the right. But how did that happen, right? How did that occur? Well, it started off with essentially what I would call simple tool replacement. So, classically, an architect would have had a drawing table. The table is purpose-built for making drawing easier or more effective. They would have had pencils and things like that. And that was obviously replaced at some point by CAD software. So, in other words, tools on the computer that directly replaced the tools that the architect uses in their life. And you could say the same thing about the telephone. That was replaced by email. Maybe you could say similar things about other ancillary tools. So for instance, you could talk about the contract. What did a contract look like? And you could also say, well, maybe modern contracts are digital contracts, and there's digital signatures and things like that. And so, we've replaced some things. That's great. But how do we become more efficient? How do we see more of that chewy goodness of efficiency? And so the next natural step is to start combining things together. So in replacing many of these things were replaced by software engineers for differing domains. And you could say, well, that software engineer definitely left a bit of a piece of him, her, themselves in that product that they made. It's impossible for the creator not to be seen somewhat in the creation. And so you could say the same thing about the next step. So how do we do this? Well, now we build a system in which maybe the customer says, hey, I need some architecture work. And they go to a place, maybe a website, and then the architect, maybe the project manager who is in charge of the architect, assigns work through that portal, that place. And the work is done on that place. And the contract is proposed on that place. And the product is delivered. And maybe even downstream things. The person who's building the building, the team, is finding their information in the same place. And of course, I'm talking about a workflow, a basic modern implement. But the point I'm making here is that software engineers don't just inject their way of thinking, their worldview into the products themselves, but also, I would say even more so, into the workflows. Because their products, if you think about it, they're kind of relics, and they kind of have certain elements to them. Even within software engineering, we have examples of this. The kids these days have no idea what what is that thing that you click to hit save, right? That I think it's called a floppy disk, right? Of course, nowadays you don't really save anymore. It's kind of destroying, really. Okay, so there's relics. Those things move forward through processes, and software engineers have influence in that way, and the way that they work is injected into that as well, their workflows. And to some extent, it feels right. It feels modern. It feels like the way things are done. And of course, there's the question of why that is. Why does it feel modern? Why does it feel right? Well, I mentioned before your smartphone, but if you think about it, in many ways, software engineers hold many of the touchstones of modern society. If I asked you to name 5 billionaires, of course, most likely, you're going to name some software engineers or people who are perceived as such. And if you think about what that means, that influence came not just from the money in tech, but also in what the tech that was created was. So the person who invented the blog, the first thing they probably started doing was blogging. And most likely, they were blogging about software engineering. And so if you think about what that means, a disproportionate amount of information online relates to the culture and to the way software engineering works. If you look up an article on recursion, which is a somewhat mystical software engineering concept, there's a 7,000-word article, and it's in 27 languages. If you look up lamelin, which is many of you have, and actually all of you, it's very important to cellular biology. It's only got 1,200 words in only 20 languages. So which of those two is more important to humanity? I would argue, of course, lamelin and many other things that kind of go with that. So many of the tools that you're using have been influenced not just because of their creation, but also because of kind of the way they work. Okay, so the question I would ask is, okay, how did that happen? And I thought about this a lot over the years, and there's a concept in product design or in project management called the project triangle or the iron triangle. It looks like this. And so there's essentially 3 constraints that exist, and you've probably heard of these. There's time, which is exactly what it sounds like. There's resources. In this case, you could say that that's human resources, but also financial resources. And then there's scope, which is a fancy way of saying how much we can get done. And so these sorts of triple constraints are something that everybody deals with. You've heard of things like trade-offs, and you can only pick two, that sort of thing. But software engineers started in the same place. You could say computers used to be extremely expensive. Only universities, governments, maybe large corporations could really afford cutting-edge technology. And so many systems were set up for the use of these very expensive systems. So there were entire people's jobs were to essentially manage this system and make sure that it was used as much as possible. In some ways like a modern hospital with an MRI machine, where they're trying to get as much as possible out of that machine because it's so expensive. And of course, everybody here is aware of what happened. Computers became incredibly cheap relative to past times. Even the latest MacBook Pro with all the features you don't need is cheap compared to computers. I have a Radio Shack catalog from 1980, and on the back is their kind of old model computer that doesn't come with a monitor, and $5,000. In $1980, $5,000 would buy you a really nice MacBook now that you don't need. Okay, so that essentially what happened was that triangle kind of collapsed for software engineers. So if you look at it, obviously time still exists, and obviously they all still exist, right? But software engineers kind of saw time and resources kind of combine. So you could say they combined into person hours. So I mentioned that MacBook Pro, which you may or may not need. And how much does that cost? Well, let's say you get a standard company-issued laptop, maybe $2,000, and some standard company-issued software, maybe $500 to $1,000. And that computer lasts for 3 or 4 years, which is very realistic. And the person using it makes $100,000 a year, which is a reasonably normal salary, maybe even on the low side for an experienced software engineer. That's 1%. That's a rounding error in terms of materials costs. And you also could even think of that as being an overhead cost, because everybody has a laptop. It's a little bit like the heat in the building or the office space or other overhead type costs. So you can almost factor that out in terms of software engineers to essentially just person hours. And so this is the 90s, and a lot of cool things happened in the 90s, but one of them was that software engineers began tinkering with the way they worked. And we've seen the effects of that throughout industries, throughout your life. It's subtle, but it started with the things that I talked about before, kind of calling back to tool replacement or process replacement. And it's grown into what we see today, which is essentially movements that came from software engineering and radiate outward toward the world. As an example, in the 90s, I think of CRM, customer relationship management, and a lot of the tools that came out of that. And that started in large part in software engineering and has kind of radiated out. But that started because of software engineers tinkering, making new things, trying new things. Okay, so what does that mean to you? Obviously, the idea here isn't just to describe a brief history of software engineering and its influence, but also to say, okay, maybe I'm not a software engineer. What can I do with that? And here's my suggestion. First of all, keep your eyes open. A lot of times, if you kind of look at the things around you, many industries are starting to look at other industries. And when I say software engineers are in the future, we are in some ways. Maybe not in fashion, but we are in other ways. But other industries are also in the future. They're in your future or in your potential future. And so by looking at what they do and making it your own, you might be able to gain an advantage. You could say in industry it's a competitive advantage, or it could be a personal advantage for you. An example from software engineering that's relatively modern is pipelines that essentially take things that software engineers have hated doing for many years, testing, making servers, things like that, and they've automated those things. And they've kind of passed their responsibilities off to the computers. And that has allowed software engineers to kind of get back to the core things that they love doing. So if you think about that, could you do that in your life? Are there ways that you can use these tools, in many cases created by software engineers, and processes, in many cases, created by software engineers to help you? Sometimes it starts with basic tools. Many people have used card systems like Trello to organize things. That's very much like something that software engineers would call agile. It's kind of our basic way of working these days. And so maybe you can kind of bring that into your life and use that for yourself. It's, like I said before, it's not really necessarily the distant future. It's the short-term future. And by kind of moving forward into that short-term future, you can leverage those things for yourself and for the companies, organizations, and things that you care about. So that's basically what I wanted to talk about today. Thank you very much for your attention, and keep looking forward. Keep kind of take that for yourself. Keep looking around. Thank you very much.